Good morning, everyone. Good afternoon, everyone, depending on which time zone you're in. Welcome to today's webinar, Subsurface Data-Enriched Site Intelligence. I'm Jacob Spinsby, and I'll be your moderator today. We have a great lineup of experts to discuss how we are using tools and technology to generate data that can help alleviate pain points on your project site and help speed up your project timeline. So why would this be interesting? Why stay to the end? I mean, I have Google Earth, I've done geophysics and drilling. What we're trying to get across here is the synergistic reimagining of the site characterization approach that is faster, safer, smarter, and clearer. It helps to reduce your risk and project costs on a site in its earlier stages where the site horrors are more manageable. In an analogous way, it's the haunted house, except we're turning all the lights on in the haunted house. So you're able to walk through the haunted house, you're able to understand what's there before you're actually under construction, really the worst time to discover that. A couple housekeeping items here before we get started. I do want to let you know that we are recording this session. We'll be sure to share the replay and the slides with you. Watch for an email with that information. Also, if you would like to receive PDH credit for today's webinar, we will share a blank certificate in the chat. It will be up to you to verify the program requirements for the states where you are licensed. During the presentation, if you have questions for us, you may ask them at any time using the Q&A feature at the top of your screen. We are going to move through the presentation at a high level, and then we'll circle back, and we've saved time to cover your questions at the end. So, we'll go ahead and get started with this great topic and lineup of experts. So a little background on Terracon here. We are celebrating our 60th anniversary this year, started in 1965 in Cedar Rapids, Iowa. We are in the top 20 E&R design firms. We do have 180 offices nationwide with 7,000 plus professionals at this stage. And our safety journey, as we call instant and injury-free, has been one we've undertaken in about the last 15 years. Part of that safety journey is that we start our meetings with an IIF moment. The IIF moment today, to synergize with this topic, is really prepare for the unexpected. So you have a site, and those project sites may have safety risks. Underground storage tanks, for instance, utilities, spills or chemicals that are on the site, snakes, insects, or animals that bite. Our agenda for today is seen as follows. We will be hearing from Mr. Philip Sinclair. Philip is a geophysical leader in Texas with nearly 10 years of experience. He's shown promising leadership in integrating geophysics into engineering applications. His work specifically focuses on applying innovative, non-destructive, and scalable techniques to our practices, including geophysics, drone technology, and advanced data visualization. Philip is known for his collaborative approach, working closely with interdisciplinary teams to develop forward-thinking solutions tailored to the complex challenges of today's infrastructure and related projects. He'll be followed by Travis Kasselbaum. Travis leads Terracon's National Stage 1 service, which helps clients better understand development risks without having access to the site. Working with a team across the U.S., he focuses on getting our clients information they need faster than ever. Travis utilizes his more than a decade of experience in geotechnical engineering and geophysics to guide the next steps for each project tackled. Philip will return after that. And then ending, we'll have realized results with Levi Denton, Vic Donald, and Mike Hegemeister. Levi is the National Director of Terracon's Geotechnical Site Characterization Services. He provides strategic leadership and oversight for excellence in safety, quality, and consistency across all projects. With over 25 years of industry experience, he's a subject matter expert in geotechnical exploration and oversees a fleet of more than 200 drilling and cone penetration or CPT rigs. Vic is a seasoned geotechnical engineer with over 45 years of experience. He served as the National Director of Terracon's Geotechnical Service Line for a decade, and for the past 3 years, he has contributed as a senior consultant focusing on the development of Terracon's central engineering and delivery program. Mike Hagermeister is Terracon's Environmental Service Line Director with deep risk assessment and remediation expertise. Mike has driven innovation in vapor intrusion, emerging contaminants, and sustainability services for over 25 years. And I, Jacob Spinsby, am the National Manager for Geophysical Services at Terracon. I provide strategic leadership and direction for the largest near-surface geophysics group in the United States. I am based out of the Denver office. I support operations nationwide, driving our innovation and excellence across the organization's geophysical initiatives. So with that, I'm going to hand it off to Philip Sinclair for a reimagined site characterization, a holistic approach. Philip?
Thank you, Jacob. So we're reimagining site characterization by implementing a proactive, holistic approach that prioritizes intuitive and efficient data collection to increase cost efficiency and safety across all projects. So what does this approach look like? How do we determine what data to get and the best way to get it? And where should we even start? Clients typically come to us requesting either specific tools we can offer or results we can produce. Terracon has developed a vast toolbox of collection methods, technologies, and data analytics for the civil engineering industry, and that will only increase over time. Clients also want the results we can produce because we provide and create those tools our impressive roster of interdisciplinary experts need to apply their knowledge. These two starting points encompass the majority of our client interactions. However, they tend to leave out important opportunities for multidisciplinary collaboration. There is a third option that we believe would provide the best engineering outcomes if we were to start there: goals. By broadening the focus from targeted tools and results to project phases, this allows Terracon to provide more comprehensive project plans by incorporating experts from a wide variety of fields and expertise. However, it's very difficult to put together a comprehensive scope that spans across these multiple engineering disciplines cohesively. And so the role that Terracon performs at the beginning of a project will most likely determine the opportunity and ultimately the effectiveness of using this roster of experts. So let's take a look at the roles that Terracon can act in on any given project. When we start with tools, for instance, we'll provide specific results by those tools, and hopefully this will lead to helping you achieve your goals on the project. But there's no partnership happening in this relationship, so we're most likely acting like a contractor. When results are the focus, we're getting the opportunity to now select the best tools to produce those desired results, which has a much better chance of achieving some of the big goals of your project. That's more of a trusted relationship, but still not a partnership. So this would make us a consultant. But when we start with goals first, now we're thinking of multiple phases of the project, incorporating experts that can provide insight into what information in the beginning phases would be beneficial to have as the project continues developing. The input from these experts determines the desired results, and then the best tools are chosen to efficiently produce those results. We're now starting with the end in mind, like an advisor. This is the partnership we're looking for, because this is where you will receive the most benefit from working with Terracon. So what does this look like in practice? Well, imagine someone wants to build their new headquarters on a beautiful area that seems to be a quaint, peaceful, and undisturbed location. Well, if we assume the role of a contractor, it might look something like this. You come to Terracon asking for some borings and lab testing. We want 4 borings, one on each corner of the proposed building location, and then one in the center. Tell us what you find out, and we'll take it from there. This is preliminary. We don't need to know very much. Going quick. So we can do that. And the results that you receive will be primarily dictated by the tools that you have now requested. So we can give you some valuable information, but it's limited in what you're seeing and ultimately the goals that we are helping you with are also going to be limited. So we might be helping you select a site, but that's pretty much it. That's all our focus is. In this situation, the disciplines that we've involved so far are geotechnical, exploration, and laboratory services. Now, let's take it one step further. If we assume the role of a consultant, you're asking for some foundation design, depth of rock, some bearing pressure, settlement. You're getting a little more information. You want some results. So now, because we're starting with the results, we get this opportunity to tell you these are the best tools that we think we can offer to get those results. So we recommend let's start with the stage one. Gives us a good idea of what's going on in your site without even getting anybody on there. We want to incorporate maybe some geophysics because we saw some things from the stage one that might be beneficial for us to start with some non-invasive methods, screen the area a little bit, and then we actually recommend doing CPT instead of going to borings on this site. We think that'd be a more effective way of exploring your site. Now that will ultimately help with a few more goals. We're doing site selection still, but we're helping with some building design and we're mitigating some risk along the way. Because we started with the results, we're incorporating more disciplines. So we start with the original three, geotech, exploration, and lab, but we're now bringing in some remote research and some geophysics, and we're getting a lot more information. But if we were to start with the role of an advisor, starting with those goals first, the first goal might be just site selection, but we're gonna have the other project phases in the back of our mind as we're going. And so that's going to help us determine what experts do we need to bring in. Maybe we need to bring some environmental. Maybe we need to bring some of our materials leads or some structural engineers to take a look at, hey, they have some plans for the future. What can we do later on? What can we do now that would help us later on? And now our results are going to be dictated by that pool of experts looking at the same project and helping you think long-term about your project and not just for today. And so now we're adding in a couple of environmental hazards, maybe some things on the constructability side that could cause issues. And so then we still want to tailor fit the best tools to efficiently get as many of those results as possible. So the list of tools have not dramatically increased, but we're just able to target the best tools for the best results to lead to these big goals that we have. And so I know what you might be thinking, oh, how much is this going to cost? Also, how long is this going to take? Well, it's important to view the project as one single operation with multiple phases that all affect each other. For example, if those buried foundations that we might find later on that we did not identify in site selection or in the design phase, when the earthwork begins and they're finally exposed, the whole operation stops until we figure out how many there are and what's going on, or what's going to be the cost to remove them. Can we redesign around them? Who hasn't run into that issue? The second important point is that each progressive role has been adding less field intensive and time consuming tools. So predictive tools like Pivot in stage one, they direct the entire process, illuminating expected site conditions, and screening tools like geophysics and remote sensing that we were able to incorporate as we changed the role that we started with. Are allowing for more strategic exploration plans. And as you can see here with our disciplines added, we went from just 3 to now we have 8 different disciplines all looking at the same project. And so to summarize this reimagined site characterization, like an advisor, we're starting with the end in mind by looking at the project lifecycle and focusing on the goals first, which promotes a partnership between Terracon and our clients to get various experts on your project as soon as possible. By prioritizing faster, safer tools first to more precise yet intrusive tools last, we build layers of confidence on top of each other, leading to more efficient, safe, and cost-effective project outcomes. So with that, I'm going to hand it back over to Jacob.
Thank you very much, Philip. All right, Travis is up next. He's going to talk about remote research, subsurface environmental, and geotechnical data.
Yeah, thanks, Philip. Thanks, Jacob. You know, being involved early as an advisor in the project lifecycle can really help our clients save both time and money. Often, the geotechnical and environmental concerns on a project aren't considered till later in the project phase, after the client has already invested money, sometimes lots of money, in economic considerations, location, preliminary design, development, as well as other due diligence activities. When we can identify these constraints earlier in the process, let's say an underground storage tank or a sinkhole, or like Philip mentioned, buried foundations, we can help plan around those challenges earlier in the project. And this can drastically help with the planned budget for your project, as well as maybe make the decision early on to maybe even abandon the site altogether. Over the past decade, we've developed these tools to help our clients identify potential constraints earlier in the review process, but really bridging that gap and providing that information faster than ever before. One of the ways we're helping accelerate that data collection of information is through an acquired company called Pivot. Pivot really transforms the frustrating manual process of gathering and verifying site data into a streamlined digital experience. Pivot is an interactive georeference platform that consolidates land, social, and environmental data into an easy-to-use format. It really maintains hundreds of data layers, over 280 million data records. That's a lot of data. And our geotechnical and environmental professionals can quickly understand the site constraints by reviewing this data that's compiled in Pivot in just a few minutes. Additionally, Pivot is available as a SaaS platform. We have numerous clients that use this tool as an early screening tool to really validate or quickly eliminate sites that they're considering for development. Instead of combing through various data sources for environmental constraints, parcel boundaries, and permitting requirements, users can upload their own assets and access the curated third-party data sets through an interactive cloud-based map. This platform allows engineers, developers, project managers, and pinpoint potential risk quickly by toggling multiple data layers. Some of the layers are like wetlands, endangered species, regulatory zones, among others. By automating these critical data gathering steps, Pivot slashes project planning by up to 50% and reduces the risk of costly miscalculations during those early phases of the project. Ultimately, Pivot delivers concrete business benefits, faster go-to-market times, more accurate permitting processes, and better informed decisions that drive project success. Whenever clients need that additional consulting expertise to weigh in on their projects for the environmental and geotechnical concerns, we recommend doing a stage one. Stage one combines a powerful tool of Pivot with our historical knowledge and expertise for each project. It summarizes the data reviewed into an extensive report that clients can use to compare multiple sites, really guide them through the next steps for their project, what to consider, and what next steps they should be doing. It all starts with a review of the data. Again, going back to Pivot, pulling all that information quickly and easily. Next, we review our historical geotechnical data, which I'll talk more about shortly, considering our virtual soil profile. And in some instances, we have data reports that are more than 100 years old. That's a lot of data all across the country. We engage our local geotechnical and environmental experts to weigh in on the data. They review that data and then help develop the site-specific concerns and what those preliminary recommendations are for your site. We leverage our national footprint in our dedicated Stage 1 team, in my opinion, the best team out there, the Stage 1 team, to rapidly turn around the deliverable with consistency throughout the process. Finally, we deliver that report via our powerful Compass platform, where clients can access the report, communicate with our team, communicate with other parties that are invited to the project so they can all digest that early information together and understand the preliminary information and make a decision on how to move forward with their project. Every Stage 1 project is delivered through our Compass platform. So back to our historical data. We've created a software called Virtual Soil Profile, where we're able to access our historical information. It's created from our historical boring data. We use some predictive analytics, and the information is further refined by our local geotechnical engineers. As time goes on, we continue to add data points with every additional boring drilled, every site investigated, to really further develop our model utilizing this information. You can see on this map, the central and eastern portions of the map, you see a lot of green. Green is good, as in we have sufficient coverage. We have good information. We have lots of data to really understand and predict what may be encountered there. There's approximately 1.6% of the area with no data. Likely, you're not going to be developing in these areas. They're probably deserts or remote areas with little information. But should you have a project in one of those areas, call Terracon, because we'd sure like to fill our data gaps. Just about anywhere in the US, we can predict what would likely be encountered should we drill a boring at that site. The data continues to improve with each and every project we do, as it all combines to our database. In addition to geotechnical data, Stage 1 really provides good insights on the subsurface environmental, natural, cultural resource considerations. It offers information that would otherwise be difficult or time-consuming to collect. The preliminary design recommendations, constraint identification, and development of our smart work plan are all completed by our local experts familiar with the project area. So how does all this begin the development of the advisor process? Well, let me just share a quick example where we did just that. Terracon was engaged in a project very early on in the project lifecycle. The facility was looking at a new wastewater treatment plant. Due to the existing facility being compromised by a sinkhole that opened up and made their existing facility no longer usable. So the client was looking for a nice, large, flat piece of ground that would be able to develop in an ideal location. If you think back to Philip's slide with the ideal site with all the flowers, they were looking for just that. They had two sites in mind, the one identified by the green outline polygon, the other one in the red. The orange polygon was their site that they encountered, was their previous site, and you can see the sinkhole that's mapped on there. All those orange dots that litter the project area are all map sinkholes by USGS. So we worked with the client, we worked with the civil engineer, and looking at those two locations, doing our Stage 1 report, we were able to identify several sinkholes as shown, but then also we looked at the depth of bedrock. The depth of bedrock map showed that the one site that's currently outlined in red was lots of shallow bedrock. That's not going to work for a wastewater treatment plant where you have deep pits planned. That's going to increase the cost. So we were able to help our client recommend further investigation in the site in green. Part of our Stage 1, gave them the preliminary design information they were looking for so those engineers could proceed with their work, but it also provided them with the next steps. And part of the next steps that we provided were, hey, we think you should do some geophysics. There's no sinkholes mapped right here on site, but we know this area is prone for karst formations, sinkhole development, and that's a good way to check the site out to see if there's something there that could be of concern. There's more to this story, but I'll let others talk about that later in the presentation. For right now, I'm going to turn this back over to Jacob and learn how our rapid data acquisition can be a natural fit for many of those projects early in the project lifecycle.
Thanks, Travis. And before we move off of this, as a client, what do I get from a Stage 1? What does that look like?
Yeah, you get a great report, in my opinion, of lots of preliminary information, geotechnical, environmental concerns covered, as well as some preliminary design information. So often our clients can use that report to begin their design, understand the risk, and help them accelerate moving forward with their project.
Fantastic. Thank you, Travis.
Thank you.
We'll move back to Philip Sinclair again for rapid data acquisition, screening the site.
Thank you, Jacob. So rapid data acquisition is a different term than what most people are used to, but screening a site. I just wanted to give a better definition of what does it mean for us to say we're going to screen a site. So I put a definition here just for everyone to kind of be on the same page. It's simply collecting surface to subsurface data with minimal to no destruction required. That's the broad term, and I put a list of all these different tools that we have at our disposal to work with. And this is obviously not a complete list because there are so many more tools that we can utilize, not only tools that are available in the industry, but also tools that Terracon has developed in and of itself, so that we can try to find newer and better ways to collect data that historically was either inaccessible or incredibly difficult or cost inefficient to get that. So now that we've seen all these, all the tools that we have at our disposal, you might be thinking, that sounds great, but how am I supposed to remember all these methods that you're showing and what to do with them? Well, you're in luck because that's my job. So instead of explaining all of these methods to you, I'm just going to give you a way to remember the benefits of using these screening tools. So going back to the advisory role, just thinking about it in that term, if we go through the workflow of goals to results to tools, we've assessed our goals at this point. We performed our remote research that Travis just explained what that looks like and what you get from that. And we have determined now what results are we after. And now we're in the tools phase. We're trying to look what's the best tools to use. So we want to use the best tools to garner as much information across our site as possible to increase our confidence in what has already been predicted from that remote research, from what we already know. To remember how tools like geophysics and remote sensing enable a better understanding of the Earth beneath us, just think of Mars. Map, agile, rapid, safe. So we're going to go through these one by one. Map. Geophysics, screening, all these screening tools help collect data, especially laterally, very quickly, very efficiently. We can map out large areas and try to find either hotspots or best targeted locations for the borings or the CPTs. It's a great transition between the two, or it can just map out what's our concern. So some examples here is like, where's the best place to core on this parking lot? I have an idea of what the depth to rock is, but where should I drill along that? And or can I flip it and say, I have a boring, but I want to know how consistent is this boring information laterally. So now we're getting kind of to do it both ways. And so or you have a concern about contamination. So where's the best place for me to be sampling across this site instead of having to kind of pick and choose and hope for the best information when you get into a more intrusive method. Moving on to agile. These tools tend to be much more able to access much more difficult locations than traditional methods. So in or on water, limited at drill rig access, either because of steep elevation changes or because of heavy vegetation. Getting under bridges, you can use drones and for inspections under bridges much more efficiently much easier than it is to try to access with just a human climbing up to inspect bridges below. Or confined spaces, we're not dealing with as many concerns of confined space or small spaces that we can't access with our larger rigs. We can move them with some non-destructive testing. Rapid. So now we're implementing drones. We are hooking up equipment to vehicles that can move at up to highway speeds, depending on what the goal is that we're trying to achieve. We're attaching, we're letting vehicles do a lot of the heavy lifting so that we can collect data much more efficiently across our sites instead of setting up static soundings all the time. And finally, safe. Because we're implementing newer technologies, because we're allowing vehicles and drones to take on the majority of a lot of the field labor by using these screening tools, we would most likely be encountering a lot less site hazards as often. And so anything from biological hazards with thorns or rattlesnakes or just snakes in general, you don't have people walking on the site nearly as much whenever you're implementing screening tools. Because we're not being as intrusive on a site, we're not running into the concern of running into a utility or a UST, underground storage tank, as frequently. Better yet, because we can map things, we might identify these types of hazards ahead of time pretty early on, so there's even more benefit to that. And just one example on the safe side, inspections can be done much more efficiently, but also safer in that this asset tag on the top left would be something that we would want to make sure we take a picture of. But if we're going to inspect the entire structure, which is right below it, we would have to scale all the way up, meaning somebody working at heights. But this asset tag picture was taken from this far away using a high resolution drone camera. So now we can do these inspections in a safer manner because drones are giving us access to new areas. So again, just think Mars as far as some of the advantages for using these screening tools: map, agile, rapid, safe. These can give you valuable data across your site. And as you might guess, the sooner the better for using these tools, since the sooner we use them, the better understanding you'll have about what's going on across your site. So just one thing to pick up where Travis had left us off on that real project study he alluded to, there's more to the story. We'll go ahead and fill that in a little bit more. So following the stage one, Terracon performed geophysical testing across the client's preferred site location. And our geophysical tests identified what appeared to be some sinkhole activity in the middle of the field. The great thing about this was that we were able to somewhat confirm what was already been shown, but confirmatory borings at this point weren't even necessary because we already had two separate tool sets, remote research and geophysics, corroborating each other because the ultimate goal was site selection. It wasn't we need to build right here at this point in the project lifecycle. So this provided enough information to move on with like minimal field effort, minimal damage to the site, and minimal cost to the client. And so getting to see the new area, because we identified this early on in the project lifecycle, the design team was able to relocate the facility to this new green area to the north to avoid any apparent sinkholes. Had we waited until after final design, the costs to redesign or remediate the sinkholes would have been extremely costly and caused major project delays. Things would have been even worse had we never performed the testing to begin with. A traditional boring layout with 4 to 6 inch borings could have easily missed this apparent sinkhole, and they could have built directly on top of them. So crisis averted on that one. Now I'll go ahead and hand it back over to Jacob so that we can learn about the next phase of implementing the holistic approach, unless you have a question.
So Philip, some of those pictures, very colorful, look like very colorful treasure maps. What do I do with that information? They just look like watercolor paintings. So how do I handle them?
Yeah, so there's the technical side, but it's more so what is it telling you? So every data set that we would be collecting is real data. It's just how do we use it? How do we put it all together into painting a bigger picture of what's really going on? Where you have broad stroke background in the painting, you also have the fine-tuned shadowing and lighting that you want to add all of it together to create the full picture. And that's what geophysics does. It's trying to create the bigger picture by giving you maybe more targeted information, but on a broader area.
Great. Thanks, Philip. Hand it over now to Levi Denton for us to talk through realized results, data-powered field exploration. Levi?
Thanks, Jacob. So data-powered field exploration, what do we mean by that? Well, it starts with choosing proper methods and an execution approach for our field exploration that's based on data that we already have at our disposal. And I'll just, if you'll recall what Travis said earlier in the presentation about what a stage one delivers, and that might be a new term for a lot of people on the call. The stage one is a well-informed prediction of what we're going to encounter on the site. And it's informed by data sources, geologic mapping data, previous exploration, maybe us or others have done, aerial imagery data, many sources. And the culmination of that stage one report is a smart work plan that details the tools and the plan that we're going to use to confirm that prediction that's that's outlined in the stage one. And that's what we mean by we say a data-enriched field exploration. To be clear, we're not going out to a site exploring Mars, or uncharted territory. And the process we're talking about today, where we do it this way, is a significant departure from applying a generic geotechnical or environmental exploration scope to every project. It's going to be tailored and custom. Once we have that idea of what we can expect to encounter, then we have all the tools there available to explore the site. Many tools are listed here. They're not all here, and depending on the conditions that we're expecting to encounter, to confirm, we're going to select the proper tools. So you'll see here there's a standard penetration test, and that's kind of like the tried and true. If you've been doing geotech for a while, you always see the SPT. But there's so much more. There's cone penetration testing, pressure meter test, dilatometer, vein shears. There's a new emerging technology called measurement while drilling out there on the scene now. We can do additional geophysical screening type studies. There's a lot of environmental tools, advanced environmental tools, high resolution site characterization tools, membrane interface probes, hydraulic profiling tools, and all of these tools you can put on a different kind of carrier depending on what kind of site access conditions you have. So a lot of different permutations of what we could select there. I won't go into a lot of details about all the tools or all the carrier types, but I did just want to share an example where CPT, for example, might be used instead of a traditional SPT exploration program, and how that might impact the project. For starters, all tools can't do all things, and they aren't all suited for all locations. And that's true for CPT. So, and if that were the case, we'd just pick one technology that we liked that did everything, and we'd always use it, right? But that's not the case. So CPT, for example, we can use that in a depositional type environment or a softer geology where we know we can push that tool to our desired termination depth. And if we're in that type of geology and we can use that tool, then using that type of tool can yield significantly more data than if we'd selected a different tool like SPT. And I'll just illustrate that here. So in this figure, you'll note on the right-hand side of the figure a typical CPT sounding log. It's inside of the red box there, and you'll see a very fine stratigraphy, and it's got several discrete layers of interbedded sands and silts and clay, and that's all represented by those pretty colors of yellow and purples and greens. And you'll notice as we push that CPT through the termination depth, we'll collect that data almost continuously, or actually like approximately every 2 centimeters along the way in the profile. And in the next figure, you'll see in that same sounding, if we've redacted all the data in those dark red boxes there that would be missing between the 2.5 to 5 foot intervals if we did SPT testing, for example, which is performed further apart, you'll see that we miss some things. And the next, and the reason why we miss it is because we take a sample and we go to the next place and you assume what's there is the same thing until you get to the next sample. And in this profile, you'll notice that it further emphasizes what we missed. So if we reconstructed this profile using those 2.5 to 5 foot intervals, you'll see that in the red box on the left, we've got a large blocky area of a silt or a sand or a clay, for instance. And it's because we had to assume, again, that what was above is the same thing below till we hit the next sample. Contrast that with the right side and in the green box, where we've taken much more samples, many more samples along the profile every 2 centimeters. You can see the fine detailing in the nature and all the things that we picked up that we would have missed if we just kind of skipped those intervals. And you may be asking yourself, is that a big deal? And the answer is it could be a very big deal. And in this case, thin sand lenses within a silt and clay profile can provide preferential drainage paths to relieve pore pressure as you load up a site with, for instance, your new embankment fill or your large structure. And what that does is it will significantly speed up the rate of settlement that's happening. And that might be important for your project. And you need that extra data to understand how long that settlement would take. And in this example, that extra data is important. And then just to highlight here the amount of data we're talking about in a typical 50-foot boring, an SPT program would have 12 N values that we take along the way in that profile. Contrast that with a 50-foot CPT sounding, and we would have collected over 600 data sets in that same 50 feet. If we had applied measurement while drilling technology, and that's emerging, that would be a nearly continuous profile from 0 to 50 feet. And we'd be measuring things like torque and crowd pressure and advancement rate. And that's something that's emerging right now. And that could even eventually replace the SPTN value. So the interesting thing about new technology, whether we're talking about geo and environmental or even your cell phone, is that most of the time these new technologies are not only applying or providing more data, but it's also faster. It's more efficient. It's coming in quicker. For instance, on CPT, we can typically do about 3 or 4 CPT soundings to 1 SPT drilling in the same amount of time. And what that can mean for a client is more coverage for the same cost, or we could do the same coverage for less cost, for example. And as we collect all these massive amounts of data for the project, more than ever before, the next step is that we convey all that information in a clear model or visualization that brings all this information together in a way that enables some data-driven consulting to happen with our project team and clients. And the goal here is that we're making things that were really unclear before really clear to the entire project team, all the project members, the laypersons, the geo and environmental concerns. They all can understand what's happening because of that visualization. And that visualization, which enables that consulting, coupled with now our collaborative engineering with the team, that's what makes this process that we're talking about today unique. We believe this approach, when done just this way, is going to reduce your risk and your unknowns on a site, and the things that can delay projects, the things that cause cost overruns. And those are the big risks generally when we're talking about subsurface issues, whether it's environmental or geotechnical perspective. So with that, Vic, I know this process that we're talking about today, it's really been a vision of yours and a passion. I would say more like a passion. And just, could you give our listeners here today some words of wisdom from either your past or your crystal ball looking forward, what you see happening with this process?
Sure, happy to. And Levi, for those of you who don't know us that well, Levi and I have been working together 15 years, and he knows I've been smiling through this whole presentation as we talk about what can be. The opportunities for 3D visualization are here and now. The question is, can we embrace it in the profession? I'll ask you a question, Levi. Today, on this warm Wednesday afternoon, how many exploration teams do we have out there getting borings done or CPT done?
It's 200 of ours and 300 if you add in our good subcontractor partners.
So of those 300, how many are doing SPT only borings?
Most of them.
So 90%?
It depends, but I would say probably I would say 70 to 80% are performing exclusively SPT type testing.
So today, as we're talking about these great new methods, we are out pounding on a steel rod with a 130-pound hammer, deriving our data-enriched results. So I think the message, the word of wisdom, the crystal ball here is we need help from the profession, from you, our clients, to move us into this area. We're out telling people that the possibilities are here now to really enjoy a data-enriched service. And I'm so excited to hear Travis and Philip and Jacob talk about geophysics and predicting conditions with existing data so that we walk out and build a smart exploration plan to get this work done. But how can we actually move this to where it happens and this smart work plan is accepted by the clients, by the client's client, perhaps by a Department of Transportation or some licensing agency? We've got our work cut out for us to embrace what technology allows us to do. And when I think about, for example, when I think about measurement while drilling, that's a term that, unless you're a geotech, you may not have heard it, but it means instead of pounding on that auger on that rod with a hammer, we're actually measuring the amount of energy that it takes in drilling that hole. So you combine that with Levi's discussion of CPT, it's a dramatic improvement, a infinite amount of additional data. And by the way, it takes that infinite amount of additional data to render a drawing like this beautiful drawing that Levi's given us an example of. And so we now have the historical data at our fingertips, the innovative test methods to get this done, and we are building and improving every day on this 3D visualization concept. What we need is the ability to shed this century-old paradigm of drill, test, report, and move to the paradigm that Philip, as a young geophysicist, has explained to us today. We can be an advisor to you guys, not an order taker consultant, but we can use these tools very proactively and very productively. So I think what I would be asking this group is to help us shed the old ways of doing it and enter the 21st century with these new technologies. Well, ways, how can we start to collaborate around this? You know, I've been doing this 45 years, and I hate to think about how many times I put a soil boring plan together that shows the location of 30, 50, 100 logs, and then this big book of boring logs, and I need to give them the sticky finger goo to put on their fingers to raffle through and find the right log. And we're kidding ourselves to think we're actually pulling that data out. We can do that now. This computer will give us this data. Not only that, it will look like a video game. We'll be able to start to look at this data live, collaboratively with our clients, with design team members, talking about risk. We don't know enough about this area. Geophysics would help us do a better job to evaluate this. And it could really save you some money if you get that geophysics data to understand. Good example that Philip and Travis mentioned. And the what if? What if we cut 3 more feet on this site? How would that change settlements? On the fly engineering. That's where we're going. And we have the technology to do it. It's time for that paradigm shift to get us all there. And I'm getting too old to wait. I'm ready to get this done right now. So whatever we can do with this group to help us move forward. My message to you guys is I'm glad you're informed by this. I hope that there's a call to action here. Reach out to the people on this call, or perhaps there's someone with Terracon that you know better and are more comfortable with. Reach out to them and say, hey, these guys gave this webinar about this. How can we be more proactive on my project? I want to move faster. I want to know conditions better. Please help us move in this direction. We're anxious to get you there. So those are my words, Levi. Jacob, I think I need to head it back to you.
Great. Thanks, Vic. Yeah, and you know, one of the other tangents here and equal partners in this is if, you know, Mike Hagemeister on the call, you know, how does this apply to environmental? We have high resolution site characterization, but are there opportunities to do these same processes through, you know, through the environmental services as well?
Yeah, Jacob, thank you for the question. And as I think about this, we're talking about smart plans, right? Smart plans. Many of the people on this call are aware of what phase 1 products are, so on and so forth. And that is, our industry is largely driven from a due diligence standpoint into that world. But geophysics, you know, geophysics is a wonderful tool on the front end when we recognize there may be ghost tanks on a site or something like that. We can start using geophysics and things like that to pinpoint where that ghost tank may have been, so we can develop a smart sampling plan for our client. And it's tied into the development side of it. We're working with the geo side to make sure that hey, if we have contamination on that site and we have soils that are of an issue as well, we're working together to make sure that we're thinking about it bigger picture for our clients and managing that risk. And then you start getting into advanced site characterization on contaminated sites. You know, when you start talking about excavating contaminated soils, and you start talking about, and I'm talking about non-hazardous soils at $100 a yard, it makes a lot of sense to make sure that you know exactly how, or very closely, how much material you're going to be on that project. And that's where we can start actually working with our clients on negotiations and things like that, and helping them through that process, because it gets expensive very fast. And you go into high-res site characterization services, we can really pinpoint what those costs might be on the front end. So there's a lot that can be done there. Helps with site closure processes. Vic talked about visualization. That's key as well in our world as well. So many things from that standpoint, Jacob.
Yeah, great. That's fantastic. Great, Mike. So we will finish the last 10 minutes here with our Q&A session. You can type your questions into the Q&A feature at the top of your screen. Additionally, contact information for myself and Levi Denton, who leads our site characterization services, is also on the screen. So feel free to jot that down if and as you need. As we do wait for questions to roll in here, I will ask this group, as the client, what's the value to this? How do I take this message back and sell it to my client as the client, potentially the project owner? And I'll just kind of start in a similar vein to, how we did the original run through. Travis, from a stage one and pivot, what's the value to me doing that from a nuts and bolts standpoint?
Yeah, no problem, Jacob. Thank you. It's a good question. Question I'd say we hear often from clients, what's in it for me? How can this actually save money? We've had multiple stage one projects that we've done for clients where we've identified challenges on a project site, and those challenges were either unknown or they maybe knew about it, just not to the extent that they were. And some of those challenges actually made clients say, hey, this site's not our site. This is going to be too costly. One example, we found a cemetery in the middle of a golf course. The client was about to close on the deal, and they were informed by us that there's a cemetery out there. We confirmed it. It killed the deal. They're no longer pursuing that project. There's also the aspect of not just finding those big problems, but let's say you do have a good site. We're able to provide that preliminary information so the client can really move forward with their project with greater confidence. They've got preliminary design information about the subsurface. So all that preliminary design work that they do, they can really take and use and understand and move further, with better information.
Great. Thanks, Travis. I'll circle back on that in a second here. We did have a question from a listener. Levi, on the CPT example, what was the geology that we saw in that example?
Yeah, so that geology that I saw there, I don't recall exactly which part of the country that was from, but it did look like it was an interbedded geology with like sand, silts, and clay. So pretty typical of a depositional environment. Could be anywhere USA, down in our coastal areas. Back earlier in the presentation, I had a map that kind of highlighted areas of probable success with CPT. So it kind of could be anywhere, kind of hugging the coastline from all the way up in the Northeast down to around the panhandle of Florida and going into Texas there. Really, any areas where we can push and not hit a refusal obstruction is where we could encounter that. I don't know if that was the nature of the question. Do you want to know specifically about that log or where we might be able to do CPT? But happy to elaborate more on that.
Additionally, while I've got you, Levi, we had a listener state that they've used Bentley iTwin integrated with OpenGround, Leapfrog, OpenBridge, OpenRoads, etc. How does this 3D characterization work for projects across disciplines and integrate the design to a single model first design process?
Yeah, so I think the main thing is to collect the data in such a way and take care of the data structure so that you can share it with others. And that's something that's really emerging right now. There are a lot of software vendors out there actually trying to solve that problem. There's a movement, if you will, called DIGS, and it's geared at standardizing the data exchange for geotechnical information. And we're a participant of that. And so what that would entail is, all that data being collected, being structured and formatted in such a way so that if someone wants to incorporate that into their model, that they could receive not just a picture of your data, but they could receive the data itself and then be able to use it in all these tools, kind of like what the listener was asking about with Bentley or Leapfrog. And it could be plethora of other softwares. It could be, Autodesk, AutoCAD Civil 3D. It could be lots of platforms. But the idea is that the way that we structure the data is kind of agnostic so that we could apply to any software.
Great. Thanks, Levi. Vic, you've been a big proponent of innovation and exploration methods. What changes has Terracon seen in the last 10 to 15 years in terms of moving away from the traditional exploration methods, such as standard borings? Also, with Terracon's in-house data and geophysics, potentially, can the boring frequency be reduced?
Yeah, Aether, how you doing? It's good to hear from you. It's been a while. I want you to know you were an inspiration to me all those years back when you encouraged these type things. So thank you. Well, what we've been talking about really is what we're doing in Terracon. We've had a massive effort. We've got a program we call the CPT First program. We're trying to get all our practitioners to become comfortable with it and to use it whenever possible. We're bringing the assets, which is a very expensive proposition, to the offices so that they can have economic use of CPT capabilities. And the far more exciting thing to me is measurement while drilling and where we're going with that. The ability to collect this data by measuring the force to turn the augers, et cetera. And to your point about in-house data reducing boring frequency, absolutely. There are many times when we can say, we're real close to this. We just need to confirm, not to find, but to confirm. But sometimes, Aether, we might add borings as a result of our stage 1 data, or we might add pressure meter tests or something unique to really get to the heart of the issue. And I think that's what Travis was touching on. And while I'm talking, Jacob, I was dying to answer your value question. Can I do that?
Absolutely, Vic.
I just want to talk about, I'm a geotechnical engineer, and most everybody in this call probably understands what factor of safety means. Factor of safety is a ratio of the design capacity of an element to the actual load on that element. So you might want a factor of safety if you're a structural engineer of 1.5 or something like that for your loading a column. Well, in geotechnical engineering, it's not unheard of to have a factor of safety of 3. That means you've got 2 times more concrete going in the ground on a drill shaft, or two times longer pile, because that factor of safety has to include a factor of the unknown. The more we can densify this data, get geophysics to look at uniformity, get the CPT test to show the high resolution of that data the way Levi demonstrated, the lower the factor of safety we can go. So you can actually have a less expensive foundation, which, by the way, last I checked, cost a whole lot more than the geotechnical study for that foundation.
Thanks, Vic. To the group here, potentially Levi, you and Vic, what typical limitations would we expect to encounter on this type of deliverable, referring to the 3D visualization? And how do we now communicate that to a client if very provocatively we're moving away from words on a page and models in a model space? How do we deliver that format, and how do we communicate that potential risk or the risk of unknowns to clients?
Go ahead, Levi.
Oh, we've got to mute. All yours, Vic.
So repeat the question just to make sure I get it right. I don't know.
So what are the limitations we'd expect to encounter on a 3D deliverable?
Okay.
And then how do we communicate those limitations?
The limitations on a 3D deliverable, as I saw in some of the Q&A, is it's not standardized yet. I would love to drop my data into a client's data, and they were able to bring it into their Civil 3D, make their cuts, drop their footings 10 feet, 3 feet, whatever it might be, and understand the results of that. So we're working hard behind the scenes to build something that we believe we can do effectively, efficiently, and standardize that.
Great. Thank you, Vic. We do have some other questions in the chat, but out of respect for everybody's time, we will call it here. We can address those questions individually after the meeting via email exchange. So I do want to thank everybody for joining today's webinar. I want to thank our panelists for joining and speaking so well and articulately. Everybody have a great rest of your day. Have a very safe day and a good rest of your week going into the weekend. Thanks all.